do I decide where to actually place an AI workload in a hybrid multi-cloud AI infrastructure? In a previous episode, I made the point that, almost every infrastructure today was built and architected before generative AI. And so it's a good time to pause and rethink your infrastructure in general. This idea that you can use a single cloud for everything makes very little sense in the AI world. But on the other hand, the actual answer might require some thought, and you might decide which clouds and what should be hybridized and what should be run at the edge or in a device. And we made that case, and hopefully you agree with me, that if you have an infrastructure strategy that predates generative AI, this is a good time to pause and rethink it. Today, however, I want to go a little deeper, because let's assume you get through that exercise and you realize what I think is an obvious answer, that AI is pervasive, it will exist in many places, it is quite complex, it can be costly, it introduces new risk, it's got lots of dimensionality to it, and you realize that the best way to build an infrastructure to support that is to have a diverse infrastructure. In this case, we'll describe it as a hybrid infrastructure, where you can decide to run an AI workload on a device or in a physical edge environment or in a private, completely controlled environment like a colocation or a data center or in a cloud. Once you understand that because of the nature of AI, that distributed architecture is actually a requirement, then you get a second question. And the second question is, well, if I have that type of architecture for my infrastructure, now I have a series of workloads. AI is not a singular thing. In the enterprise, each AI workload usually addresses a business process or a business function. There are different tools that are used. And so deciding within that topology where you should place that workload needs a bit of a framework. And so we've been thinking about this, and I want to share with you kind of 4 dimensions that I think help us decide where we should put workloads, given the fact that we have an option of putting them in a public cloud or a colocation environment or a data center or an edge or a device. We have lots of choices now, but deciding what parameters dictate which choice we should choose is actually the next level of detail. So the 4 that we are using today are, in no particular order, cost, risk, location, and predictability. Let me walk through them. The first parameter of any type of AI workload decision should be around what is the actual operating cost of this thing. These things can be incredibly expensive. AI, in many cases, is consumable as a service. It can have consumption pricing on it. It can use APIs that charge you money. There can be per seat licenses, per instant licenses. It's a very complex world. And if you're not careful about the cost structure of your AI environment, and specifically how those workloads run in it, you could find yourself in situations where the ROI is significantly diminished, maybe even goes away, because it costs you more to actually do the AI thing than the amount of money you save or the business impact. Generally speaking, any AI project, if you don't have clarity about what the actual upfront and operating costs are of that solution in the way you think you're going to deploy it, you should probably not proceed. However, if you do understand that cost structure, it starts to become very interesting depending on where you place it. So, for example, in the old world of the cloud environment, one of the reasons we went to clouds for certain use cases is because they were infrequently accessed. They ran occasionally, and I didn't really want to have a bunch of dedicated infrastructure that ran at 2% utilization. Things like email are good examples of that, or certain databases. And the elasticity of a cloud environment, even though it costs more in many cases per unit of consumption, was incredibly appealing. In the AI world, our experience has been kind of the other. When you actually have high priority use cases, not random science experience, but you decide you're going to transform your sales force and you're going to transform how you write software, these types of workloads run at extremely high utilization levels. They, in many cases with agentic, you can have them run 7x24, 365. And it turns out one of the worst workloads to put into, for instance, a public cloud, an as-a-service environment, a consumption-based environment, is a workload that just simply runs all out all the time. In fact, those types of workloads, if you put them on dedicated infrastructure that you can deploy as CapEx or completely optimize, actually have up to 70% less cost over the long term compared to these kind of ephemeral environments that we're not actually using. So from a cost perspective, one, it's important to measure it and understand it, but then the cost of your infrastructure and the choices you make to use it will vary depending on that infrastructure capability. Public cloud's great for as a service, consumption-based. They're actually really good if it's kind of bursty and not constantly running. AI workloads tend to run at higher utilization levels. So when you start to look at putting them into colocation, putting them into dedicated infrastructure, even potentially moving them out onto edge devices where they just run perpetually, the economics tend to be better. There are many ways to measure economics, but our first observation is when you think about your new hybrid multi-cloud topology, when you choose to place a workload on it, you should not do it just because the functionality exists at that particular place. You should do it based on, initially, what is the actual cost of running it there, because you'll find dramatically different costs, up to 70% different, running the exact same workload in two different places in that hybrid topology. The second dimension is around risk. Now, we all know this. At the end of the day, your business's most important asset is what you know, the proprietary data you have, the digital skill or the skills that you are able to deliver. And we need to be fiercely protective of those. At Dell, we are very, very protective of our data. We believe that if we were to give up all of our data and expose people to all the capabilities we have and just let them exist in the wild, we may not be a differentiated company. And so we choose not to do that. And so in this case, again, depending on the workload, if the workload is using data that, quite frankly, is not sensitive and is already public, like marketing data, then you have a lot more choice about where it would run. Your choice of on that continuum of infrastructure will probably bias towards cloud or SaaS, or you could run it in a private environment. But from a risk perspective, if it's already public data, you're not gaining much there. On the other hand, if the data is stuff that you need to fiercely control, that has extreme regulatory risk, we know that running it in a private infrastructure is the safest choice, full stop. And so again, there's a continuum, but when you look at all the choices you have, how do you measure the cost and the risk of those two environments to ultimately make the decision about where this workload best belongs? The third dimension is location. It's an interesting thing about AI. AI works based on the fact that the AI system is given data in inference time and does something with it. It turns out that in most enterprises, most modern enterprises, almost no AI activity begins its life or ends its life in a public cloud data center. It begins in a store, on a car, in a hospital, in a home, in a factory. The reality is AI is very much about the real world. The idea of doing clinical care in a hospital involves data from patients in the clinical setting and information happening in a hospital. And so because of that, we know that more and more in the AI era, deploying AI where the data actually lives and is processed is actually essential. And so again, not all data exists at the edge, but if the data exists at the edge and it benefits from being processed at the edge, if you have a hybrid multi-cloud topology, then probably the best place to deploy the AI is where that data lives. If on the other hand, this data has no location sensitivity, then this probably isn't a big factor and you can focus on risk and cost to make the decision on where you place it. But again, a third dimension. Even if it is highly sensitive data and it is extremely cost sensitive, but there would be a benefit of running it close to where the data exists, it may lead you to building a secure edge as opposed to choosing some other option. And then the fourth dimension is predictability. One of the challenges with the AI world is as you become more dependent on a wide range of infrastructures, those infrastructures have their own life cycle, their own economics. And what we've seen recently is obviously as GPU prices and memory prices have changed, it creates some level of unpredictability about what is actually going to cost me and what am I getting from the providers I have. The more you are abstracted away from the underlying technology stack, that you have no direct control over it, the more likely you are to be surprised by a price increase or a functionality change or the deprecation of a model. And so while that isn't always bad, and we've seen this before when certain foundation models moved to an X version and the old one went away, but the behavior of the new one was different, the use cases dependent on it, in many cases, broke. And so that's not a predictable environment. But it turns out not all workloads need high levels of predictability. If you're just talking about general purpose AI activity where you're summarizing information or doing some basic processing or generating imagery, continuous improvement and having some level of unpredictability as long as things get better is fine. But if on the other hand, you're talking about a fine-tuned model or a RAG system or an agentic environment with knowledge graphs that's very specialized in its capability, you need to make sure that the infrastructure it's running on is actually extremely predictable. The behavior doesn't change, because if it changes in a way that impacts reasoning or decision-making or even performance and user experience, that could actually have a consequence to how you sell, how you service, how you actually develop technology. And so the fourth dimension, in addition to cost, risk, location, is predictability. And across that continuum, the most predictable environments are ones that you fully control, that you have complete control of the stack and you've made all the decisions. You do not need that for all use cases, but there are some use cases that you absolutely want that level of cost and functionality predictability because they correlate with a process that cannot tolerate kind of random behavior. On the other hand, there are definitely use cases that can handle that kind of variability and evolution, and it's perfectly okay. But the trick is to know whether or not that workload requires high degrees of predictability or it's okay with a lot of variability and change. Understanding that correlates to the kinds of infrastructure. Shared as a service and even SaaS services tend to be more dynamic and they tend to change more frequently. Private and dedicated infrastructure or even specialized infrastructure at the edge tend to be much more stable and predictable, and the behaviors of the AI applications on top of them don't drift and change as much and don't create as many unplanned surprises. So again, this is an ongoing dialogue. We started with the fact that you're going to have to rethink infrastructure. This is a second level of detail that once you've done that and have a new topology, placing workloads on that infrastructure must be a thoughtful experience. You must think about multiple dimensions. The four we're using today, cost, risk, location, and predictability, tend to be a good framework to decide where the best place to run that AI workload is, given that we now have a choice of places to run it. So hopefully this is useful. Again, we'll continue this dialogue. And as we talk about use cases in the future, we'll talk about the idea of how we decided not just how to build the use case, but where we decided to run it, because that's almost as important as the use case itself. So again, hopefully that's useful, and this will be an ongoing conversation. And as you think about your infrastructure, it's important to get into the details and know that that infrastructure is not built for a single application or a single outcome. It's a platform for your AI outcomes across your entire company over a long period of time. And so you need to be smart about where you place those workloads and how you fully utilize that infrastructure.